I have indeed no real use case like the previous one. But I try to share with you what we understand with the with the previous capacity building projects that we had. And first thing, international cooperation projects in general serve different purposes, but typically they want to enhance the knowledge on scientific, technical, and managerial topics related to the veterinary field. Among these different type of projects, today I would like to focus on capacity building projects that want to strengthen the capacity of member countries to prevent, detect, and respond to emergencies concerning animal health. So aquatic ecosystem is very complex, and for sure the projects related to this kind of ecosystem are complex because we have to consider various interwoven aspects. First of all, we saw different case studies before, environment, so all the natural characteristics and elements that describe or define the aquatic ecosystem itself. So, for example, the different type of water. We talk about aquaculture activities that for sure have to consider this kind of environmental characteristic, but also, as Nicola mentioned a couple of seconds before, we have to consider structural aspects. Also, you have to consider which kind of animal you have inside, you know, the management aspect. So it's pretty difficult to consider all of them. And finally, the technology. Nowadays, working aquaculture activities, it means have a lot of data, especially received from sensors, for example, probes. We talked about that before. And for this reason, technology have to be considered. So from a theoretical perspective, consider all of these aspects, it's pretty tough. Yeah, for this reason, in this kind of project, we work in teamwork. So each individual can contribute with his own background to achieve the final goal. And for this reason, the capacity building projects, it's something that are able to highlight the complexity behind a specific topic, because you can exploit those topics, and also you can tackle this kind of multi-phases challenges. So I'm just a GIS guy, okay? So I can just to speak about this field, we can say. And in general, from our previous capacity building projects, the main elements that every time we consider are essentially farms, laboratories data, the water component, we can say, and the contextual data. They have their own specific aspects, they have their own specific features, but there is one thing that probably it's in common between them, which is the geography, so the spatial information. And usually, the spatial information is a good starting point, we can say. So, talking about farms, in general, we work in we split it in two main components, the administrative and production component and the geographical component. So speaking about the first component, it's the set of attributes, or in general, the set of information that try to define the farm concept, and the farm concept in a sort of unique way. So a unique reference that you can use if you want to, you know, attach further information, subsequent data, like for example, laboratories data. What we saw is that all those information can for sure store in a farm registry, but sometimes, or often, these farm registry are not present or are not uniquely recognized. And in those cases, every time we try to suggest to create something very easy, never mind which kind of technology, but something very easy and very effective to try to acquire the information about the farms as soon as possible. Other times, those information are present. There is a farm registry, well-defined farm registry, but maybe is not implemented for the veterinary purposes. And so it becomes very, very tough and very, very difficult for the veterinarian expert or the guys on the field to maintain updated data. And if you don't have the updated data during an emergency, yeah, we have a problem, we have an issue. One thing that is, usually underestimated, but working with Nicola especially, you have the occasion to talk about is the use of the unique farm code. So if you talk with an IT guy, probably he say, oh yeah, don't worry, put a number from 1 to infinite, and that's okay. Yeah, but it's a mess. Understand which one is the right farm using simple a number, a digit, okay? If you talk with a vet, probably say you can use the farm name. Perfect, but the farm name can change. And if you don't know very well your territory, probably you don't understand what happened. So there is always this kind of discussion and try to find the right balance to try to create this kind of unique farm code with the other guys during the project. And you have to find something easy, but not too easy. Something, that is self-explicative, but not too long. So it takes some time, but usually it's very useful in the end. Geographical representation. Every time someone asks, okay, please tell me what is the right primitive or geometry that I have to use. Always the answer is depends. Depends on the farm composition, the scale of operation, which kind of analysis you want to perform. So essentially it takes some time, but you have to discuss about that. From our experience, usually the point is the most used representation, but in fish farm, freshwater fish farm, depends. We have to discuss about that. Okay, I put the technology thing just because in general, if you don't have nothing or very poor database in general, it's not important the technology. You need always, get the data. But after data organization, when you define how you can collect and maintain, probably the technology take an important role. So you have to think about that. Laboratories data is the basis of epidemiological and surveillance component, probably, okay? Never mind if it's paper or information system. But nowadays, we have LIMS, which is the Laboratory Information Management System, and there is a lot of institutions that already have their own well-structured LIMS, very powerful, very strong. There is a problem. Sometimes it's not integrated with the farm registry or with the GIS system in general, okay? But if you think about that, it is very important, the integration, because if you are integrated in an integrated system, you can reduce the errors. You have a lot of information that are present in the farm registry already available. So you can reduce the time for the data acquisition for the laboratories, of course. And in the same thing, if you have a GIS, you are able to quick represent and visualize the data. Also, for example, only to know if a point is in the middle of a farm or not, or outside. So every time during our previous experience, we push and we try to say that the system integration is very important. We know which is not simple. This is another aspect, but every time is important in our opinion. The water element probably is the most distinctive element of the aquatic environment and freshwater system, because it's water, okay? I say that I wrote there an hydro word because you can have different approaches on the representation of the water elements. You can use like, hydrographic representation, which usually is something that helps you to represent, maybe on the map, on a WebGIS, or in general, in a graphical way, the different elements. And it's more or less what you need when you start at the beginning. But if you want to really know or understand some events or some problems or issues, especially in the veterinary field, probably is not enough. Maybe you have to think about how it works So hydrological representation or modeling, like considering, for example, topological relationships or simply the direction of the flows and so on. So in general, this kind of representation is very powerful because you try to model the data, the spatial data of the water element. And you can perform some analysis, like for example in freshwater fish farm, upstream, downstream, and so on. But in that case, IT plays a fundamental role. So from our experience, for sure, we reach the first hydrographic representation, and sometimes we are able to work at hydrological level, we can say. But in general, we had some experience in the first one. Contextual data, yeah. We talk about farms, we talk about sampling sites, everything. That is something that is already produced in-house, we can say. So veterinary services, candidate institutes are able to produce this kind of data. But there are other information, like for example, satellite imageries or other contextual data, which is not available or producible in-house. In general, you need to use external repositories, someone produced for you. And nowadays, as you mentioned, there is a lot of online services that offers a worldwide coverage. They are for free, data for free, available for free. And in general, this kind of information allows you to understand where you are, respect of what you have around you, which kind of elements are present around you. But from our experience is not enough. Probably the most important thing is try to get in contact with national mapping agencies, because probably they already have the know-how to work on GIS data. They produce some data at local level that sometimes is very precise. And one thing that sometimes is underestimated, it's already prepared with the same coordinate reference system that you use for, the map for the decision makers, for example, which is quite good in the end. So sometimes, or in general, the data for, for the public organization are for free, but sometimes they can they can ask some charges, but depends. Yeah, final message, I think, it's, I say technical aspects in general, but indeed, the most important thing, in my opinion, is try to establish a pretty common language, we can say. So among the experts, but not only about among the experts, because if we are able to produce something, a solid, or we can say a solid communication, we are able to produce something that we can call knowledge base. And if you have this kind of common knowledge base, we are able to put some bricks on the air and then move for further analysis or further frameworks, so further discussion in general. So I'm a GIS guy, so from my perspective, from GIS perspective, we can say, have a knowledge base could be, for example, define the same thing with call the same thing with the same name, so same nomenclature. Define the common concept, what is a farm for us, for example, okay? So in the end is try to define together and share this knowledge about the GIS entities, well-defined GIS entities. And with this in mind, with this goal in mind, we try to create a sort of a conceptual feature catalog that we think could be a good solution or support to try to have a good knowledge base. So when you have a knowledge base, for sure, you can discuss about systems, framework, technology, how you can use, maintain, analysis, and so on. And for this reason, we are trying to work to produce a sort of framework that allows, for example, for everyone to start from the scratch and create your own GIS system, we can say. As a final remark, but indeed we already talk about that, in general, technical aspects are usually manageable. So are tough, are difficult, yes, but usually manageable. in my opinion, organizational challenges tend to be the most complex. So it's not so easy to convince managers. It's not so easy to organize a different institute because they have their own problems. They have their own, activities. So capacity building projects are tough also in that way. Sustainability, I don't want to talk about that because I think we already discussed before, but is the key, probably. So thank you very much.